Hello, everybody, and welcome to this Sparring Partners. This is the second Sparring Partners on APIs, and it's a topic of my next report. So there will be more about it. And today we talk about APIs as one of the hidden gems. One is network APIs, and the other one is digital twins, and how together they actually are going to help digital innovation for service providers and for the whole ecosystem, in fact. And it's a great topic. And before I introduce the guests, let me do a little bit of housekeeping, which I often forget to do. So as many of you are familiar with the format with Sparring Partners, we do have questions, but we take them throughout the event. There is no Q&A at the end, so that we can answer your questions as you have them. So they fit into the flow. So do not wait at the beginning if you want your questions to be asked, even if they're not related to what we're talking about specifically at the time. Any question you have, just put it in, and we will get to you. There's a question that comes up all the time. Yes, the video is going to be available offline, and also we will have the transcript. So you can either read it, listen to it as a podcast, or watch it. It's entirely up to you. Said that, let me introduce my guest today. So I have Sameh Yamani, the CTO of VIAVI Solutions, who has been working on this for a long time, as a great vision on APIs and how to integrate APIs in our networks and how to make sure they work. And also on that, we have David Nathan that is going to answer some of the questions offline. So he's behind the scenes working very hard to get all this to work. So again, ask any questions. Don't wait at the end. And with that, I would like to introduce to you Sameh Yamani, again, CTO at VIAVI Solutions. Sameh, welcome.
Thank you, Monica. Thank you, everybody, for being here. This is a great topic, and I'm very happy and excited to be part of this discussion, which I think it's a critical discussion at this point. I mean, as Monica said, I've been working in this industry for almost 25 years. Working with VIAVI, and before that, I was CTO of Telecommunications Communication. I was the CEO of a company that VIAVI acquired. So this topic is very dear to me because I see that we are at an inflection point right now, and I believe the industry needs the APIs and digital twin. And I think the discussion today will open up a lot of ideas and challenges as well.
No, absolutely, and this is what I've known you for a while, and what I really appreciate is the fact that it's not just the shiny part. We're going to be looking at the challenges, because if you don't, then it's very hard to actually take advantage of the benefits. The benefits don't come. You don't enjoy the benefits if you're not willing to meet the challenges. So we will do both. Okay, yes. So let's just start it out with APIs. Nothing new. They've been around for a while, but why are we talking about them now? And what is it? What is the urgency of the APIs at this point?
Right. So I mean, let's go back a little bit. I mean, for years the telecom industry, has operated in a certain way. It's a closed networks, focusing really specifically on delivering connectivity while keeping the complexity behind the scenes. I mean, that's the idea of delivering these kind of services. And look at that. Since 2018, I mean, telcos have invested almost $1 trillion, in network upgrades to get 5G, but still they are struggling to fully monetize this 5G. And you know, if you also understand the history, this mirrors past missed opportunities, you know, like with streaming video, voice, and message apps, where others benefited from the telco's investment. So now there is a risk of also missing out on 5G true potential. So I think that this idea of traditionally closed network model is no longer sustainable. I think we need to provide the ecosystem, the developing ecosystem, with more access, more, a way to have, applications running on this network benefiting from it. And network APIs gives this more access to the network features, allowing them to create new and innovative applications. They can also help businesses, launch exciting products and services. With network APIs, developers can, enhance, for example, user experience, or creating something completely new in terms of how you use automation, or how you create AI systems, and build applications with IoT devices, and control these applications. So I think this is where network APIs are really critical right now, and it will help the industry, the telco specifically, monetize their infrastructure, but it also spurs a lot of the innovations in the industry and the ecosystem. Now, I think have been a lot of activity around that. We have seen some application. I still believe we need more. I'm not totally satisfied, and I'm going to discuss this in more details during our discussion. But I believe that this is a great opportunity for the telcos to actually start monetizing their infrastructure.
And I guess it's a good timing also because of all the automation, AI, virtualization, and they're all going to come together. And we're going to get to it because it's a little bit complex, the whole interaction of all this different sort of moving parts. But
Right.
that's actually what makes APIs more valuable. And there are different types of APIs. There's network APIs, vendor APIs.
Right.
It's not just one thing. Now, as you say, it's a great thing. It's a lot of
Yeah.
opportunity. However, things might also sort of go wrong. So we need to make sure, as with everything, I guess, but so APIs are no exception. What are the challenges? What can go wrong? And then we're going to get how can we fix it? Or how can you make sure we know about it even?
Well, there are different challenges. I mean, the path to monetizing, 5G network, or other part of using these APIs, as much as it's filled with opportunities, there also comes significant ideas and challenges that you really need to think about and innovate about. So first of all, to build these APIs, there is a lot of complex integration with existing systems. I mean, assuming that this is going to be a completely greenfield network, or a greenfield API running on these elements, is not realistic. We're going to have to, merge this with existing systems. So one of the key hurdles that in integrating APIs, with the management platforms, with the current network infrastructure and support system, which can be very resource intensive and complex. And of course, that's one of the ideas we're going to talk here about, the digital twin, because this is one of the, ways to telecom can address this and adopt a modular, more agile integration strategy, allowing for incremental approach, incremental upgrades, incremental addition of these APIs depending on applications, and used, now, as you mentioned, the automation and the cloud native capability that is coming with this kind of digital twin and microservices, to provide kind of seamlessly integration with this new API capability. So that's one big challenge. I see also, I mean, it's always a balancing act here. Is almost like, you're walking on this tightrope, and you have to balance between opening in the network, or opening in these APIs, and security, of course. This is a very challenge that is striking, this right balance between, having robust network security and fostering an open ecosystem that encourages innovation from third-party developers. So this balance is very crucial. And again, we're going to talk about the concept of digital twin here. I call it a canary in a coal mine, right? You can actually start opening up without having to impact your network, and then start testing and opening the innovations for the third-party application and developers, and implementing this kind of layered security strategy that includes API gateways that manage access, and at the same time manage the encryption and data privacy, as well as still opening up for innovation. So that's another big challenge. Market competition is another challenge where you're going to have to compete with already the over-the-top players that are already providing this API. So I argue that you need to come quickly because there is already market for that out there. So there are a lot of different challenges: regulatory compliance. You need to understand regional differences. So there is different things, but in many cases, I believe just opening up the APIs and creating this kind of balance between how much you want to secure for how much you want to be able to innovate is a key point to actually make this ecosystem work.
Yeah, and as in many things, it's a balancing act. It's your
Yeah.
decision how long you want to go, and um, well, sorry, how far you want to go. And one of the things is like exposing data. Okay,
Right.
so in a way, it's a good thing. In a way, it's a bad thing. So you want to expose network capabilities, but it's also something you do not necessarily want. I mean, you want to decide what to disclose and to whom, and you
Right.
want to make sure that what you disclose is accurate, which is
Right.
it seems like trivial, but you might not have good data to start with.
Right. Well, yeah, it is true, and I always say that eventually, if we're gonna want to use AI, which we want to use AI, because I think, as you mentioned in the beginning, that's one of the major changes that will allow these APIs to be more automated and so on. But AI depends on data, and your application will depend on these data. And the more data you have, the more your AI will be less biased, because if you start with very limited amount of data, will be some bias in them. So you need more data. And of course, more data also exposes some of the privacy issues and so on. So that's why you really need this balancing act. We have been doing this in VIAVI actually for a long time, when we collecting a lot of data for RAN optimization, for example. Some of our AIOps already use a lot of their data for capacity management, for inventory management, and we know a way to anonymize these data and provide still the same kind of patterns and behavior that you really need to create new innovation applications. And again, we're going to talk about this when we talk about digital twin, but the idea is that actually use the AI to actually train the data and anonymize it in a certain way, but expose the patterns and behavior. So I don't really need to know XYZ when there, but I need to know that these kind of patterns, these kind of movement patterns, these kind of behavior patterns, these kind of application patterns can be something that you can use for some of the data application. Now, of course, to improve the performance of the network, you really need more data and more accurate data, but there is a way to do that.
Yeah, absolutely. And so let's move on to the digital twins. Why in all of this? Because you could just say, well, traditionally what you do is that you have something new, you just go by, I wouldn't say trial and error, but you do your trial in the lab and then you move in the field. Digital twin is a little bit of an alternative to that kind of approach, isn't it?
Absolutely. And maybe let me share something with you to explain this a little bit, because I want to show it in a real test case. So let me share this with you. Uh, so in a lot of different ways, when you look at, we start working with 5G private networks and some of the applications, for example, smart agriculture. I mean, the idea is that you want these applications to be able to build a network slice, right? And this network slice be using the network API. I mean, I argue today we're not even there. I mean, I think still we are doing a lot of this in more manual mode. But the idea is, eventually, this is the holy grail, is that you will be able to access the network APIs, and you will be able to create from end to end a network slice that supports a certain application. Now, here is the problem. You really need to be able to actually understand how can you scale it, what kind of parameters you need to have there, how you can optimize it. You don't want to do this on a real network. So you really need to build kind of a digital replica of the network and the service infrastructure, and be able to build your idea of emulating IoT interactions, saying, okay, I'm gonna do this, I'm gonna add these kind of cameras, I'm gonna add these drones, and use kind of a machine learning model to train this digital twin on real life data. So you're talking about data, you need to bring in this data, bring in the RAN information from a real network that has a lot of these data, train this, create this digital twin, and now you can start building the application on top of that. You can start testing, certifying, looking an innovative way of building your access network. Try different service policies and have the data that is from a real network, not just synthetic. I always, I give this analogy. Think about this digital twin is almost like the flight simulator for the network, right? Traditionally, a pilot, before he goes in on a new aeroplane, he has to go and live into a flight simulator, and the flight simulator is simulating a lot of realistic scenarios. But in many cases, they actually do bring in real measures from a real flight, and then you create these kind of what if scenarios. Think about the digital twin for the telco is the same thing. You want to be able to create an environment, not synthetic, not just theoretical based on just protocols, but based on real data. And that's one of the areas that VIAVI actually has a unique position here, because as well as we provide simulation data, we also provide tools for the network to be able to test and verify and troubleshoot and collect 24/7. So we have all of these data that you can bring in and build this digital twin. Same thing. Let's say you're not just when you build the first time. Let's say you're gonna upgrade or APIs changes. API, in fact, that's one of the biggest things. It's not one time in a snapshot of the data. API will change. API will have different modes. You'll have the new release. How are you going to upgrade that? How are you going to even know that this new release doesn't break something? So predicting the effect of the upgrade, that's one, again, canary in a coal mine, right? Use the digital twin to actually test this upgrade on and test application upgrades on. Give the application this kind of CI, CD, CT on the digital twin. Do the calibration there, right? Before you actually do it on the real network, so that you can actually know how physically it's gonna work. Play this kind of what if scenarios using large and real heuristic historical data and machine learning data modeled through RAM propagation scenarios, mimicking the real environment. So this is another thing. But also, more importantly, use the digital twin as a scalable platform for the apps developer. It's almost like I'm going to iOS, provide me this sandbox, but provide a sandbox that is real. I want to create an innovative application and run it as if I'm running it in an AT&T network, right? With all the scalability, with all the kind of corner cases that may happen, or I'm trying to test it on a private network for a port authority, where we can test realistic data, all these containers with scaling up. So you don't just test in a sandbox. I think that's one of limitation I see today. You're testing in a sandbox that only provided limited capability. You don't know, then you have to go and test at scale. And in many cases, network operators are worried. Can your application scale? How I'm going to test is going to scale? This is a kind of solution for that. So these are the kind of things I believe, you really need the concept of digital twinning.
And also, you see that oftentimes when the network goes down, it's because there was some
Yes.
mistake or whatever,
Right.
yeah, it's human nature or whatever technology. So it happens, but this is exactly how you can put yourself in a situation where you minimize the chances
Right.
of that happening, because and conceptually, digital twins is nothing new. Again, it's kind of like APIs, but now we can do it because not only we have the data, you can just get all the data from the network, but also because with AI you can actually do it in a reasonable way. So because if creating a digital twin uses requires resources that you don't have, you can't do it, which was in the past, right? So now this is where AI comes in, because
Right.
you can do a digital twin
Absolutely. Yeah.
in a realistic way without going absolutely crazy and needing incredible amounts of resources. And you have the data. I think that's an important thing. You have
That
no,
is
you know, you
true.
have the data, you have access to the data.
Right. I was saying AI is not new. I mean, yes, there is a big hype right now, and there is a reason for that. But AI is not new. What is new is exactly what you said. We have digitized in the last decade or so a lot of the data. We have access now to a huge amount of data that we didn't have before. So now AI can really be trained to be more realistic. Computing is going down as well, and that's why you can build this digital twin. In fact, one of the ideas we are working for kind of innovative installation technology that we build this digital twin at the edge of the network. So even people who are going in and installing antennas or doing some work at the edge can actually have a complete digital twin of the network running very close to the edge, close and some. And that because computing and power is now available and the data is available to do that.
Yeah. Okay, so maybe I like the metaphor of the flight simulator because if you've ever done it, it's like it's a very realistic, can be a very scary experience too, right? I mean, I guess here too, like oh my God, look at the network
I
is
argue
up.
that you will not gonna go into a flight where if this pilot didn't train on a flight simulator before, right? You're not gonna do that.
Absolutely. No, absolutely. Well, actually, the problem is that they rely too much on the flight simulator, maybe, but it's still a good
True.
thing. It's still a good thing because yeah, well, like I said, that's the thing is that now you wouldn't trust unless you get that kind of training, and I guess it's
And
gonna be the same thing in for networks.
and in fact, you mentioned something really important. It's not just one-time flight simulator. There has to be a continuous feedback loop because you will see something odd that didn't happen before. Bring it back into the flight simulator so the next time he's training is seeing all of this exceptional that he didn't see before.
Yeah, so the digital twin keeps growing. It doesn't
Right.
kind of show up and go away. It's not a pop-up digital twin. It's like stays with you.
Mhm.
Uh,
That's true.
and I guess maybe you can give us a little bit more of a sense of what it is that Um, okay, let's put it this way. It's a digital twin, so you want to duplicate some things, but do you want to do? I mean, how big of a twin? How does it work? How do you make sure that it's similar enough to give you the information you need? I mean, how much detail you need to have
Right.
the
And and
whole
and it and
network,
it
part of the
yeah.
network. How
Yeah,
does that
and
work?
it depends. I mean, and I will give some example. It really depends on application, but you have the capabilities to do at scale. In fact, today we provide a similar one we're doing with our Open RAN technology, where you really need to test interoperability, so you can test it on a digital twin. You don't read the full scale. You just need okay, vendor X, vendor Y. You can build a digital twin between that, but then before you go to an operator you really need to scale it up. I mean, how can I do this with, 10,000 subscriber on this cell? Or, there is a situation where I need emergency and there is a disaster and I only have these cells but I have all of these capabilities that I need to do. I mean, there is a lot of different modes. And what we do today is we have this scenario generation where you decide what the scenario you want to really build. And then the digital twin will create the data behind it that is matching this scenario depending on what you really need. So it's a lot of different scenario generations capabilities with this digital twin.
Yeah, absolutely. So if we have digital twins, does it mean that we do no longer need labs and network testing?
I think that actually is the evolution of the lab and network testing. I mean, we've been doing simulation in the labs for a long time. I think we just need to, the complexity, that is happening today in the lab requires the digital twin. I argue that this is the natural evolution of lab and testing. That's why in VIAVI, we're taking this seriously because this is really where the industry is moving, right? As I said, the same thing, we open, a lab, first lab as a service, actually now because of the capabilities of doing this in the cloud, the lab itself can be as a service. You cannot afford just building all of these components and testing in the lab. You can now build this digital twin as a service, and you can create this scenario generation and do it. So that's the normal evolution of the lab today. In fact, let me tell you a little bit of a life cycle because
Yes.
it's very important. Um, so, I argue that there is four different cycles of how the digital twin is helped, right? One is at the beginning, you're designing, you're trying to develop a new app, a new idea. You're trying even to develop the API itself, right? So this is what we used to do in a normal lab. You do a lot of UE, IoT emulations. look at the RF parameter, the RAN parameters, you start emulating that. But now you can start doing vertical simulation, not just, just parameterize, this is the interface XYZ. Now you're trying to say, okay, no, I want to build a vertical. I want to build this kind of application, right? I want to create patterns, right? Not just traditional, okay, here is the traffic. No, I want to create traffic pattern that is as close as possible to real. This is during my design and development. I'm not yet testing, I'm just designing. So I'm trying to figure out if I do this design, what's the different features I need to put there. Design how the app is going to be experienced by the user or by the vertical or by the industry. So you can, again, these are the things that digital twin can help during the development and design time. I'm not even talking about testing, just developing and design time. Now you develop the app. Now you want to go in and start testing it. Now you're going into certification, compliance. I mean, a digital twin can also emulate all of these different scenarios that you're going to see in a compliance matrix. What kind of performance you're looking for. Interoperability. Oh, I need to work with XYZ, for versus this. You can actually start certifying based on that, right? Looking at security vulnerability, right? That's another thing that digital twin can help. Before you go in the action network, you really need to test and certify that you don't have a security hole. There are different security parameters, but there are also this continuously evolving. So this is where you need to continuously go in and test securities on these digital twins. And of course, you want to test end-to-end. So as I said, interoperability, but now let's say I'm going to run these applications with end-to-end performance. So that's the second way where digital twin helps. So not just in the development, but also now testing and certification. But it doesn't end there. Now that you're going to start operating this, running it, you really need to, digital twin for a lot of different things. And this is where also AIOps comes in place to actually help you during, the operation, to assure, to actually understand how you're going to upgrade, right? You build in more automation. So you need kind of AI trained data to actually help with the automation, right? You need to actually have this active observability. From time to time, even during operation, I need to actively test. Am I getting the right latency? Am I getting the right performance? Am I seeing some issues, right? You really need to start thinking about how you do dynamic scaling within the operation itself. Again, the digital twin can be the upfront because you need some data to be actually build the scaling. And again, even during assurance, continuous security vulnerability. So that's a third phase. And then now you go into everything is working perfectly, but I now need to optimize. And the idea is now complete optimization. How can, yeah, it's working, but can I improve more efficiency in the energy? Again, data from operation goes into the digital twin, and now you can test different efficiency models, different spectrum efficiency models, different coverage optimization. Well, I'm not seeing the coverage here, but based on the data, I have only 60% of my users are using this kind of location. Maybe I need to optimize differently. Resiliency, right? Understanding, as I'm running right now, do I have the right backup? Can I bring in the software quickly? Do I have the right microservices resiliency in this thing? And then, of course, coming feedback with user optimization, user experience optimization. So these are the four different phases. And not just the digital twin and testing, but here is AI ops plays a very important role. This is one of the things that we bring in with the optimization and the assurance piece.
Now, I have two things to say here.
Yeah.
And it's just like, as you were talking about, I just thought, the digital twin is not just a copy or like a replication of the network. It's kind of like a more of a super ego of the network in a way, because
Yes.
what you want to
I like
do
that. Yeah.
is to have the digital twin not only be what you are, but also try new things that you've never seen before. And that's really kind of, I think that's a fascinating part of AI, right? That it allows you to look at possibilities that have not happened yet, but
Right.
they might happen. Maybe they will not happen, but it's interesting to see what would happen if something completely different that we have never thought about before, and AI does that. So
Right.
how do you see that in terms of,
So
it's not
actually
just
that's a
real
great
data,
point.
it's also kind of, in a way, it's fake data, but it's
Right.
interestingly fake, it's
I was giving a talk a couple of months ago in Europe, and everybody was saying, Gen AI, I mean, it's just kind of hype. I mean, yeah, we know how to use Gen AI to create images and for chatbots and so on. but it doesn't really help in the network. And I said I disagree with that. I mean, forget about the large language model, but the foundation models that is behind Gen AI has a huge potential for the network, right? And you mentioned this is clearly. I give you a good example. A lot of the time when we do testing, we need to go in and do a lot of these test cases, right? And you go in and say, okay, I need a certain scenario. Here are the different test cases you're gonna have to pass that. And you go in and said you discover something different, you have to create new test cases. We're now actually using Gen AI to actually automatically create test cases that we never seen before, right? Now, sometimes it stresses beyond that, but it actually gets you an implication of more coverage than you have today in testing. The same thing, you want to create these kind of very complex patterns where you have IoT devices and autonomous cars passing by, people coming in, having a disaster for some kind of a weather issue. How you can complexly generate these scenarios when there is no actual data out there for that. That's another way where you can use kind of the AI, the same concept, not the same gen, but the same concept of expanding the data that you have today with more realistic data that it's not really fake. It's still being based on training from real data, but it expands the scope of these data using Gen AI model.
Yes, absolutely. And I think that that's really, this is kind of obviously early days, but you just push the network to a stress level that hopefully you'll never have to deal with, but should you know what would
Right.
happen. Now, another thing that you mentioned is the CI/CD/CT. And the
Yeah.
third one is a new one, and which is something that you sort of mentioned at the beginning, the fact that we need you also need continuous testing. And it used to be that you test the network, you're done. I
Right.
mean,
That's it.
you're done, but because the
Yeah.
network doesn't change, so you
Right.
you kind of it's like a piecemeal thing, the testing. But
Right.
now it's no longer like that. So we need the CT. Maybe you can talk about the CT a little bit.
Yes, absolutely. And traditionally networks were built by connecting, interfaces and different segments of the network, and it kind of static. So yeah, it makes sense sometimes testing when you only upgrade or testing at the beginning. But now, I mean, the network is dynamic. I mean, that's the whole reason we went to 5G. It's disaggregated and dynamic. So um, the idea that you only tested once, it's not true anymore. I mean, as we agree on, continuous, development and continuous integration, testing is a third leg of that. It cannot be ignored because you're now building these dynamic thing. In fact, testing now is I argue that before you even create a network slice, you need to test it first. You need to get the data to actually create the network slice. So it's ahead of the curve even before the development. So I argue that you have to have continuous testing. I argue that it's even more complex than that, Monica. With 6G and with some of what we're doing today with AIOps, there is a lot of discussion on having AI embedded in the network. Like the AI is actually making dynamic decision on the network, which is great. I mean, that's what we want. We want a network that breathe and expand and adapt to what the situation is and make the right decision at the right time for the right application with the ultra low latency requirements that we have there. But that creates a very critical problem. Who is testing this AI? Who's knowing that this AI is doing the right thing? How do you know that this AI is not biased, is not drifting, right? So I'll argue that, this is actually requires even more testing, but the question is testing how, right? And I may not provide the full solution there, but I can tell you one thing, and we have this saying in the US, don't go to a gunfight with a knife, right? If you if you have an AI running in the network, you need AI to test it too, right? But a different kind of AI, independent. I mean, so there is a big discussion. We may even have a different session on this AI testing AI. But I think testing is going to be an important role. And again, the digital twin with the network APIs is going to be part of that.
Yeah, it's obviously an issue of infinite regression because you have to test and test and test. I mean, use
That's
AI to test AI, test AI, test AI, and it will never end. But yeah, but yeah, you're absolutely right. You need to make sure whatever technology, and I guess that the digital twin is a way to allow you to start looking at how well AI is performing as well. I mean, as
Right.
part of the, is there a bias? Is the,
Right. Absolutely. Right.
because this is a real issue of you're constrained by the data you use for training. And if
Right.
that data is limited, then your training is going to be affected by it. I mean, that's
Absolutely. In fact, we are working first time a test and measurement company working with 3GPP for release 19, trying to actually instill in them the testing of this AI is going to require a different kind of thinking and methodology. You cannot, you have to have an independent AI first of all, and what defines an independent AI, and maybe not qualify this AI as good or bad, but at least have a meter, a bias meter, a drift meter. Because even if we say, okay, it will have to be biased, but can I improve the bias? Can I reduce the bias? So if you don't measure it, how are you going to reduce it, right? Okay, so the same thing, can I detect this drifting or how much drift? I mean, so these kind of things now has to be thought about and instrumented in this technology. And again, I will believe that this concept of digital twin will be at the center of that.
no, absolutely. Yeah. So yeah, we need to, again, as I said, the digital twin, AI, and then APIs all together make us think in a different way. But we have the tools to do it now, which
Right,
we didn't have 10 years ago, even though we had the conceptual bits.
right.
But we couldn't put them together. Now finally we can. But then I guess it's a challenge to actually get it done. I mean, it's not trivial. Just because we can do it doesn't mean that it's trivial. There's a lot of complexity into that.
Yeah, there is complexity, but we have the tools today to make it work. Right now, I
Mhm.
argue that we really need to be more bold. And this is more when we talk about the network APIs and digital twin. I think there is still some concern out there because of the challenges, because of the complexity that we're taking baby steps. I believe adopting something like the digital twin will open up the operators to feel more secure and create the application, the innovation that we're looking for. It is one thing, Monica, I believe in that with all my heart. The best application out there for this network API is the one we don't know yet,
Mhm.
right? And the problem is sometimes restricting access and say, oh, you can only do that. You can only use the data for improving performance, or you can only have access to some of these, network. I mean, in a sense, yes, you're opening up, but I argue that, we really want to provide a platform, a very scalable, very open platform, so that the next innovation can come.
Absolutely, and I think it's really important to be open. I think that if you think about back, back, the biggest killer app was text.
Yes.
And who thought about it? I mean,
Right.
it was just just something. It was just a channel. It was not meant for that. It was not designed for it. And yet, look at it. It's like it's so primitive, and yet,
Right. Right, was powerful, was really
yeah.
powerful, right?
But
It was
but
the first,
nobody planned. But
actually,
nobody
was
planned for it.
right.
You know.
And that's exactly my point.
Yeah.
But it was open. I mean, it was a by product of something completely different. It was open. But look, and people innovated, creating a complete platform using this SMS. I mean, you can actually automate a whole system
Yes.
based on that. So my point is that, we want this. We want this next level. We have more complexity. We have seeing now the industry is really ripe for, this kind of thing, because it's not anymore about just me talking to you or just broadband. It's about now business that are going to create a lot of money. I mean, there is an estimation that in the next 5 to 7 years, with this kind of network APIs, there is a potential between 100 billion to 300 billion dollar of revenue, and maybe just 10 and maybe 10 of them, 10 billion of them only for just selling these APIs, but more and more for sharing these APIs, and the operators can now operator of these APIs can now share part of that. The same thing as what the iOS and Android did with the app system.
Yeah. Yeah, I'm a little bit skeptical about the size, but in a sense that how much of that revenue is going to go directly tied to APIs. However,
API. I agree
uh,
with you. I think it's less
yeah,
than that, but
but
the
but yeah,
potential, yeah, is great.
yeah,
Yeah.
and I think that there is something to that in the sense that you need to think about the ecosystem. not just about how much money you make from selling one API to
That's
an
true.
application developer,
Absolutely.
because
Yeah,
that's a very reductive way to think about it. We need to kind of expand. So
right.
you mentioned new ways to use the technology. Can you tell us a little bit about how do we, okay. So the GSMA has, and Camara, they have a huge number of APIs.
Right.
They're not going to be all deployed on day one, right? So what's going to happen first? What are the first use cases that you see happening, and why are they interesting?
Definitely IoT playing is a very important IoT applications is expanding this model. I think there is a market for that. I believe that there is a lot of use cases that the telcos or the APIs can prioritize depending on the availability. For example, I would argue that you can build an APIs for banks using location so that they can guard against fraud. This is a simple thing because it can actually integrate into their existing process. So this is a good example and a use case for opening up network APIs to help industry solve a problem for that. I argue that you can do the same thing with hospitals trying to, have more access to patient information, provide doctors the capabilities of automating that. But there is no process there in the hospital. So maybe that's an example where you really need to develop it more, right? There is use cases that depends also on regional. I argue right now with the discussion of integrating end-to-end with terrestrial network. There is actually applications for network APIs that you can decide how can you manage backing up some of these industrial applications with an NTN network, for example. Some of these applications require continuous coverage. So what happens when you have a disaster? Then how you can switch back and go to an NTN network. So again, opening up this API for this application to be able to do that, not waiting for the carriers to do this, is a good example. So I see a lot of them. In fact, there is a lot of applications today from wearable devices, autonomous cars, mobile office. I mean, there is so many that we can talk about.
Yeah, and I guess that I mean,
Utilities, for example,
yeah.
utilities, emergency. That's
Mhm.
that's another good examples of these applications.
And I guess, I mean, you can have a limited set of APIs that then can be kind of funnel out into different for different. You just use whatever information is relevant. So it's a way to get the different ecosystem players to basically talk together.
That is
It's a way to create an interface, hopefully standardized to whatever extent you can. And so you know
And we need to understand also the regional landscape. I mean, as I said, while ideal scenario for API can be working, I mean, you want them to be interoperable on a global scale, but you still have to understand the different particulars of a geographical area. See, what thing can work in North America may be different when it works in APAC. So again, understanding this and working with strategic partners is going to be a very important thing.
Yeah, no, absolutely, that's true. um I know you've been doing some work on non-terrestrial networks and
Right.
APIs. Do you want to talk about that? Because I think that's, when I talk about APIs, it's interesting that I say, there are regional differences. In Europe, in US, fraud detection is
Right.
what first
Big.
the
Okay.
first the first mention goes there. But when you go in Asia, somehow that's no longer the case.
That's
It's not
right.
like they don't have fraud, obviously, but
Yeah.
for
Yeah.
whatever reason, that's not top of mind. It's
Right.
more
Right.
like industrial and IoT
Right.
and network slicing, because because they have more network slicing that we do in Europe and North America. So that's
Right.
part of it. But what about non-terrestrial networks?
Yeah, so I mean,
That's a new thing.
right, and it's the advance that you now can connect direct to device is pushing this industry. I mean, we are seeing because VIAVI gets involved in a lot of the testing of non-terrestrial network. So we see expansion. We're working pretty much with a lot of the LEO satellites to, have them, do a lot of these testing and how they're gonna interoperate with 5G. And again, this is again, we actually have a very specific digital twin for non-terrestrial network because, think about this. You want to develop an application. I mean, right now, most of the applications for non-terrestrial network is for rural areas where you have no coverage or for emergency services. But there is a lot of, very positive applications for maritime and different coverage scenarios. But how are you gonna even build your application? You need to be able to emulate interactions with satellites, you know, testing Doppler effects, testing latency capabilities. Again, this is where digital twin comes in place there, right? So that's another area where we're gonna see expansions of applications, benefiting from that. Aviation industry is using it. Now they also need to expand this and provide more services for people, either on a cruise or traveling, and they will be able to have access to non-terrestrial network.
And like I said, that's really a good conceptually, it's a good way to think about digital twin because you're with non-terrestrial networks, it's something completely new. So
Yes, yes,
you do not know what you're getting into,
right. And there is
regardless
a
of
lot of challenges,
APIs
and
or
believe me, yeah,
huh?
there is a lot of challenges today. There is a lot of
Yeah.
gaps, and having access and understanding how the satellite communication, satellite to terrestrial communication. I mean, there is a lot of challenges. That's why I think digital twin is a good idea here.
Yeah, and you don't have a story. Well, and like I said, that's kind of goes back to the fact of having real data. There, you don't have historical data
Right. But I
because
mean, but again, you can build,
you can build
the
it. Yeah.
action with the 5G network because you're gonna interoperate with them. So even 4G and 5G network can be used to train some of the models that can actually see, okay, if you want to communicate with this
Yeah.
kind of scenario, what data looks like.
But that's exactly what you do with
Right.
AI, with digital twins, that you can
Right.
create that kind of
Right.
data, so you can get whatever historical data you have to fit to the purpose, but you don't have direct. It's not like an upgrade. That is like, okay, let's just make this little change
No,
and see
no,
what
no, it's
happens.
not. No, yeah.
So you need to have a little bit more of a creative system in the which I guess when you think about AI, it has, well, a lot of people talk about hallucinations and whatever, but it's also a creative part. It's a creative
I mean,
because creativity is just to create something different.
right. But I mean, it is
Rather
it
than-
is simple. But although I argue that at the end of the day, it's using current data. I mean,
Mhm,
I was saying, I come more from a bioengineering background. We used to use digital twin. Sorry, the generative AI a long time ago. We used to call them genetic algorithms, right? Where you're trying to find the best local global search, and you build all of these scenarios of different search space, and you cross over them to create a new search space that you didn't think of, right? So
mhm.
it's the same thing. You have all of these data and you're training this model to create more realistic data from these in a domain that you didn't see before.
Yeah, 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 and you create a richer reality in a way. I
Right.
mean, so I don't want to kind of dismiss the real reality. I mean, but it allows you to see things that you were not really planning for. So, and this also, you mentioned before that also makes us think and act in a different way. And I think that kind of brings it back to, I mean, the way I think about it is like, it's not just, well, technology is a tool, AI is a tool, but
Right.
how you implement it makes it change. And that's where things like AIOps come in because it's not just the technology, it's how you use the technology.
That's right. That's right. And how you build a management system around this technology. AI itself requires different operational, capabilities. How you gonna use AI to, optimize your systems, and at the same time, how to optimize your AI. It's kind of this kind of life cycle.
Yeah, yeah. So how do you see the AI ops to fit into the AI digital twin? How does that work for an operator?
Well, so definitely look today at AI ops, the capabilities to build these kind of AI technology in the network. It requires a lot of different things. One is understanding the infrastructure that you have, your inventories. Now AI ops builds situation where it can, learn from all the data that you have and give you kind of accurate and more predictable inventory, more predictable capacity. Start talking about topology of the network and how you're going to use AI ops to optimize this and understanding where you're going to have resiliency, right? Then looking at observability, understanding how what is going on out there, doing troubleshooting, root cause analysis, right? I mean, that's one of the biggest problem, and we have this problem for a long time. You get all of these events in the network, but you don't know really which one is impactful and which one is not. And you spend times and times all of these alarms. Yeah, we used to use a little bit of a code book before, but even code book is kind of designed, right? When something change either nonsense. Now AI ops can do this because it get trained. It can understand different patterns and different behaviors. It can even generate its own kind of, okay, here is where I believe, the prediction of what is the next problem can look like, right? And do all of these predictive analytics, right? So these are the kind of things that AI ops can provide you today.
Yes, and so yeah, again, it's a completely different way to look at, and as I say, it's predictive to a large
Right.
extent. So well, it's
Yeah.
also predictive because you don't want to, ideally, you don't want to have the problem. You want to
You want to
avoid it.
catch the problem before, but actually I argue to yeah, predictive is part of it, but more and more important is the root cause analysis part of that.
Mhm.
Because not only you need to predict it, but you need to tell me why and how I can fix that, right? Because
Yeah.
that's the whole idea of self-healing. So that's where topology comes in place. A lot of things that comes together, and now it's even more complicated. It's not just a network. We're running on a cloud infrastructure that is using different kind of virtualization and microservices that also impacts the network itself. So this kind of AI ops can have to expand from our traditional network management and fault management to understand all the different complexity. And I believe without AI ops, I don't know how you're going to do it. I mean, expert system is still limited by the number of experts that you put there.
No, absolutely. But doesn't this kind of bring into question, or at least changes the balance between testing and monitoring in a way that this kind of becomes like you still need both, but at the same time they kind of like coexist
I
in
argue that
parallel.
it has
Because I
to feed
mean,
into each,
yeah,
it has to feed into each other. We always call lab to field and field to lab, right? You,
mhm,
you you need you need the lab data to actually help you initially define what you need in the field, but you need the field data to actually feed into back into the lab so that you have more realistic testing the next time. And it's a cycle, right? So it's not just they depend on each other, they feed each other as well.
yeah. And I guess that it used to be where if you have a single vendor, then the vendor would just take care of that. And it
Right.
would be more under their control. So it would be easier. But now
Right.
with all different
The openness.
vendors upgrading at different times, you
And you can
kind
have
of
the
have
same problem.
it's a combinatorial explosion of, like how many small things can change. And that small change here can have an impact, God knows where.
That's one of the I was talking to somebody about in the Mobile Congress, and they said we love this net APIs, but every time there is a new release, I'm worried now. Can it work? Because this vendor or
Yeah.
this part of the network has this new version, and I don't know if it's gonna be working with is it backward compatible? Was it tested for my application? So again, the concept of continuous CI, CD, CT, right? With a digital twin as the canary in the coal mine.
Yeah. But how do we, if you look at it, because a lot of APIs are going to be directed to the application developers. And okay, so you can help the network operators, the service providers, to test their own thing. But what about the application developers? Can they just trust it? I mean, how? Because from their point of view, there might be changes, and God knows what it's going to do to their.
Yeah, yeah.
I
So,
mean,
so that's why actually that's one of the challenges. we need to understand in this whole new ecosystem, right? First of all, the developers are part of the ecosystem, right?
Mm-hmm.
And you need to treat them this way. You need to provide them the right support, right? It's not just I'm gonna provide you documentation and here is what the API does. Go ahead and no. You need to provide them a platform, right? And you need to provide this platform. It's a live platform, right? And a platform can be dynamic to their need, but a platform can also interact with them. In fact, I argue at this platform has to have this AI. I mean, almost think about a chat GPT for network API, right? Where I can ask, I can understand what changed, what are the change, and it can respond. You need to be aware of that, right? You need to be aware of this new release. There is something, it has to be alive. So this is not a handover. Here is the API. Go and figure it out. Or the app developer say, here is my app. I'm now okay. I'm done. Now this is a continuous part of the ecosystem. So that's why I think it's very similar to what we're seeing in other ecosystems. It's a little bit more complex because you're dealing here with a critical infrastructure, right? So we need to understand there is risk there. That's why I think you need to put this buffer in between, this digital twin, because you give them exactly how the network is behaving realistically. I am testing as if I'm running in the real network, but without your concern about the security, the privacy. And then once it's the canary survived the coal mine, then you move it into the
One.
actual real network. Yeah.
Yeah. And I guess that, I mean, if you look at it sort of like step back a little bit, so you have different service providers, they're all doing the same thing. And then you need to have, so you need to have somebody to aggregate to make sure everything is sort of consistent.
Right.
And
I mean,
how do you,
there are two models. There is the aggregator model where you have a hub where everybody comes in. I think this is good for the developer in general because they deal with one. I think maybe it will not be a big incentive for the operators because they will take a kind of a background mode operation. There is the federated model where it's more like roaming agreement, right? Where I can work with the agreement, I can build the ecosystem, and we can, roam our APIs together, right? So that's another example. I don't know which one works. It depends, regional, depends, operators depend on their size, but there are two different models.
yeah, but I guess that, the roaming model, I think that it has some kind of bad. I mean, I understand. So I think I think I'll call it federated rather than
Federated,
roaming.
yeah, it's more federated, yeah, yeah,
But
right.
yeah, and the reason for that is because, with roaming, it makes sense for like big operators to talk to each other to have a bilateral agreement or whatever. But it kind of breaks down when you have many
API,
operators
yeah, that's
worldwide.
right.
So you need to kind of have a good way to, whether you have an aggregator or a federated model, but it's just you don't. I mean, it's not realistic for the app developer to have
You
an
have to worry about all of that. That's right. I think
so
that's
that's the scalability issue, really. And from the application developer, they cannot just start wondering, is this operator doing everything right?
Monica, and the reality is, I don't know if there is one answer to all of that. As I mentioned before, there isn't even regional problems. I mean, you cannot come and say this app is going to work. I mean, unless we are a big, you're a big, player in the big market. I mean, you always have to understand these limitations. But here is the thing. I think there is a big opportunity
Mm-hmm.
for everybody, for the industry, for these ecosystems, for the network providers, for the API providers, and for the developers. This is going to open up an ecosystem that can benefit for all, can provide innovation. I think we need that. I think the concept of AI and digital twin is going to be incremental, important engine. This API is built on software-defined network automation. I mean, all of this was a precursor to that. Now you need AI and automation and digital twin to actually make this more a scalable model that can actually go into the actual industry and make money.
Yeah, no, absolutely. And you know, as you say, it's really it's for the whole ecosystem. So it's not just to sell it to the app developers, which sometimes is presented that way. There is much bigger value than that, I think.
Right.
So that's something to keep in mind. Now we've been talking about APIs and digital twins for an hour. If there is, what is, your sort of a take home message in terms of why should we use digital twins for APIs?
I think the most important thing I will leave with is that this is an ecosystem that's going to be built on collaboration and interoperability, automations, and AIOps. To actually do that, you really need a platform that can separate between the security issues and some of the concerns and the network operators and the innovation that we needed for the developers. That's where the digital twin and API plays a very important role in the middle.
Sameh, thank you so much for sharing your thoughts with us. It's been a great conversation, and I really enjoyed it, and I hope that the audience enjoyed it too.
Thank you so much, Monica. Thank you. Bye.
Yes, bye-bye, and hold on here. Let me get... okay, so thank you so much for joining us today. And you will be able to see, as I said, the video and read the transcript, and there will be more sparring partners on APIs and soon a report as well. Well, thank you so much. Bye-bye.